IGGA. He helped do some of the work out of MnROAD, especially related to the patching materials. Now it's all foggy. And I guess, John, if you'd come up, we could kind of go through. And, you know, he was very helpful in trying to get the industry involved with the partial depth repairs that we did last year. So please welcome John.
Thanks, everyone. It's a pleasure to be here, and thank you very much for the opportunity. We do appreciate it a great deal, and I have to say I always enjoy coming to a multi-state event such as this, and you get to hear different perspectives and certainly different accents. We had the O's and the A's from our local hosts here, and of course you just had Buzz with the y'alls, and that adds some richness to the event. And I thought maybe I'd bring a little New York. So if you hear me say forget about it or use guys instead of y'all, I'm just trying to bring a little New York into the picture here for you, you know. So again, I'm really glad to be here and enjoyed the program yesterday, as a matter of fact. And as mentioned here, to give a testimonial as to why we're involved and the benefits that we see from the industry perspective and being a member of NRRA. But it occurred to me when you're asked to provide a testimonial, one of the things that you want to do is introduce yourself and make sure that you're testifying with full knowledge of the audience, knowing who you are. And yesterday it became clear to me, I've been in this job here for 20 years or so, and there were still some people after the program yesterday said, is that international grooving and grinding thing for real? I mean, is that a joke or what? And I said, you ought to try getting a hotel room sometimes, telling them where you work. So yes, the IGGA is for real. And I thought maybe if you would indulge me, I'll just give you a little background for those of you that don't know the organization, and then we'll move on from there. But yeah, I run the IGGA, and in addition to that, the IGGA is tied very closely to the American Concrete Pavement Association. And to that end, I represent the Concrete Pavement Preservation Partnership that we hold with ACPA. So in addition to grooving and grinding and surface characteristics, we're involved with all things repair, maintenance, and optimizing of concrete pavements. The IGGA itself was established in '72, and we have contractors, manufacturers, suppliers, consultants, and public officials that are involved in the organization, and we essentially promote, strengthen, and try to advance the industry to the best of our ability. In terms of our partnership with ACPA, we affiliated with them in 1995, and that's when we started what we called at that point in time the Concrete Pavement Restoration Division, or the CPR Division. And there you have our mission and our vision. The idea there is to be the clearinghouse of all things technical related to concrete pavement preservation, as well as surface characteristics and concrete pavement optimization. And we're a small organization. We have offices located in New York, Chicago, and Arizona. And it's a small group. We have an engineer, Larry Schofield, which I'm sure many of you have met and worked with over the years, who's been involved for quite some time. And we have consultant promoters that work with us time and again, and many of you may know Dan Frentress, who used to be the executive director of the Concrete Paving Association of Minnesota, who is now a consultant. He oftentimes provides services to our organization as well, and a great addition when he does. So here's what we do, and we're all over the place in terms of just trying to represent the industry and make things better for the traveling public. And these are the treatments that we involve ourselves with across the globe. And speaking of the globe, this is a list, or a short list of areas, in addition to the United States, where we have either open markets or maintained markets related to repairing and improving concrete pavement and making their pavements quieter, smoother, and so on. And that boils us down to who do we work with and how do we operate. We have a number of strategic partnerships. Of course, the American Concrete Pavement Association is one, and There's a number of chapters that are affiliated with the ACPA, and we work very closely with those organizations, such as we do with the Concrete Paving Association of Minnesota. And there's the National Concrete Pavement Technology Center, which is represented here by Mr. Gordon Smith. Hand up there, Gordon, if you would. Always good working with that group. And then there's the Portland Cement Association. But you'll notice on this list, of course, last but not least, is the NRRA. And the unique difference here with this group is the fact that we take industry, associations, my members, and we work fully with a number of different states involved with the NRRA. And that allows us to do some things that we can't otherwise do with the other groups listed here. One of those, of course, is the partial depth repair research that we've undertaken as the NRRA. And what we have is the objective here, and this was discussed yesterday, so I'm not going to go into detail at all related to the project itself, but just to give you an idea of the patching materials for partial depth repair program that I was involved with, you can see what we're looking to come up with. And essentially what we've done is gone out and created some faux repairs and then invited a number of different manufacturers to come in and to bring their products and to show their wares, if you will. And here's where it really gets interesting. Most of the people that I have on this list and the following page are members of my organization. And here's where things really get robust. When you can bring not just the association executive like myself into the room, but when you can bring manufacturers of products into the room and start listening to the needs of the group like we have here today, that's when things really happen. And again, this is page 2 of the folks that involve themselves in the partial depth repair research project. When you have members like this, people that are creating a product and they are asked to bring it to the field, put it in a live situation, and then have it evaluated against all their peers, there's a ton of skin in the game, right? These people really, really care. And I am sure during the process of installing these products, there was a lot of uptight, intense people. And rightly so, okay? They're representing their company. But again, you have people that are trying to do the best they can to impress and to show the departments of transportation that are there on site and that will be reading the reports years later, how good they can help sustain the system. So at the end of the day, with this particular project, this is what we're looking to have as outcomes. We're looking to have a guide that provides information to DOTs that are either involved, that are in this room here today, or that choose to pick up this guide years later, and they can learn how to establish a partial depth repair program. They'll know what to expect from some of these products and so on. Just really, really cool stuff, beneficial stuff that I think you'll see years worth of benefit as we look forward, as we move down the line, as we head towards retirement at some point in time. We'll remember what, not soon enough. We will remember what we've done here today, last year, next year, and so on. So that brings up the what's next. What are we going to do here? Okay, so we have products planted in the ground. Now we're going to monitor them. And we're going to come up with a report and provide benefit to those that are in the room and outside of the room as to what we're doing. But the way I view this, it's much broader than this. What's next? Okay, so we've built these sections. Well, right now, in this very room, we have manufacturers from big, well-established, name-brand companies that are here trying to listen to find out what your needs are. And while we were having coffee just a few minutes ago, one of these individuals who's in this room right now said, man, I've got some stuff. I just wish I knew the needs better. And that's why he's in this room today. If they would just ask me or tell me what they need specifically, there's an array of products that I believe that could fill the void, and there's things that we could develop. So when I ask the question, what's next, I'm thinking for myself, okay, round 2, I've got to be better at asking the question, what do we need? Specifically, what do we need to make the system better? How can we, in my particular case, make concrete work better? How can we patch it quicker, faster? How can we make it more friendly to the people that are grabbing the material, putting it in the hole? How can we make it last longer? I will begin to ask better questions. And I'm going to invite more of the members that I have that are in the manufacturing realm to come and listen to the needs of folks like yourselves. Because I think if we can get a better line of communication between the manufacturers. And again, I'm going to say, I am not a great bridge. I'm not a chemist. I don't know all these things that the people in this room might know. And I don't know all your needs, but if we can match that up, I think we can take this NRRA thing to another level. And I think the benefit that we can produce at the end of the day is going to be extraordinary. We just got to make sure that we have those lines of communication open, and we got to get some more of those manufacturers in this room to do so. So with that, I say thank you. Thanks to everybody here. Thanks to the organizers of the event for the opportunity to be here, and look forward to 2018, 2019, beyond, and the next year, and so on. Thank you very much. Appreciate it. Thanks, guys.
For our next testimonial, Soheil Nazarian will come up, University of Texas, El Paso. Soheil was doing a project that was utilizing kneading test sections, and we were able to kind of tie our research together in the works that we did with NRRA. So with that, Soheil.
Oh, thank you very much.
Thank you.
Thank you. Good morning. You know, when you leave the door open, sooner or later, a faculty would get over here and start lecturing you. So, so that's me. As Ben said, we are working on a project related to intelligent compaction for soils and aggregates, and funded by the NCHRP. We were in need of some sites, and we started talking to MnROAD that, hey, we need a site. Originally, when we wrote the proposal, we were supposed to go find the sites at different states and travel, install instrumentation, and things like that. And this opportunity came up. So the real title of this talk is how lucky we are that we have this opportunity over here. And we have you guys as a partner. So what's the goal of the project? Very, very quickly, you know, first we wanted to develop a procedure that measures mechanical properties. What that means, this is, again, coming out of the RFP. It's not my word, you know. They want to measure stiffness or modulus of the material with the roller. They want to just basically facilitate the adoption of the IC technology. It means that it has to be straightforward specification and transparent so that you can implement it. And the last one is for field acceptance. That's got us a little bit. And because as soon as you're talking about acceptance, you know, real money gets involved. So we have to be careful to minimize the dispute. We don't want every project goes to referee. So it's a little bit ambitious project, but nevertheless, we are lucky enough, you know, and got the project to work on. So the other group that I have to thank is Caterpillar. Brian is here. Thank you. And in order to do what we wanted to do, the roller, just basically the conventional IC is not enough. We need to have access to some more information from the roller. And we approached CAT, and they were very generous, and they agreed to provide us the additional information, namely the load that you want. If you want stiffness, you need to know load and deformation. So one or without the other one, you cannot do it. So this is the experimental roller, and they just basically work with us very closely, and we got us the data that we needed to collect it. And that's what we were doing. So when we are talking about getting to the model, you know, what we do right now is great for uniformity. What we're going to get the material property, you need to have a model. You know, anything you have to have a mechanistic model. For the last 10 years, we have been working, thanks to the generosity of a lot of different funders, on a final element code that just basically models the roller on top of the soil. So models are great, they make good movies, but they are as good as the prediction, you know, that so we have to calibrate these models to be able to do it. I gave a presentation last year, some of the runs on the supercomputer of UT system, which is the second fastest in the world right now. Some of them takes around 8 to 12 hours to just one. When you have a vibrating roller that is just moving and you're trying to do it. So we don't want to do that for every project, so we have to come up with a thing. But so the first step is to get the model and to answer some of the questions. The basic, what's the depth of influence of the roller? That's very, very fundamental, right? Things like that. So, but we have to have a calibrated model to answer those things. And that's where the MnROAD sites came. We started doing instrumentation at the site to measure what the response of the soil is at a different level. I go faster, Ben. So we were lucky enough, we got section 185, 186, 188, and 189 on the, I guess, that 187 got in the way, what the heck, 186, two of them are clay subgrade, and next to it, there are two sites that are sandy. Where on earth you can get 4 sites, 2 on sand and 2 on clay within 500 feet of each other, and these are really uniform materials. So we instrumented those, and we started running the roller on it, and if you see the grids at the bottom, when we get to the field, we don't skimp, we just test the heck out of the system. So we put a grade of between 30 to 40 points, and we started testing to just have a dense idea of what the non-uniformity of the site is. Yeah? As a geotechnical engineer, the first thing we learn, soil is darn variable, and we cannot do anything. We can manage it. We cannot just solve it. We manage it. So we put the instrumentation. This instrumentation is the complement of our friends from Federal Highway Administration. We have a project from them, and we developed some instrumentation. So we have a system that simultaneously we can measure the vibration of the roller and synchronize it and measure the vibration of the sensors that we embedded in the ground so that we know the relative location of the roller relative to that. And so what we do, we just basically have the roller operate, and we just measure it with time, and we synchronize the distance. What sensors we use? We have an accelerometer. Oh, I guess if I point the thing, you don't know. This is the whole system. Just basically, you put it on the handle of the roller. There is an accelerometer that we install. These are the accelerometers. There's industrial accelerometers. These are the 3-dimensional geophones. They measure the displacement, and we just put it at different levels. This is the pressure cell, and it ended up that we didn't have the pressure cell in the program, but because the cost of the travel was minimized, we are doing all the testing in one place. We just basically took the travel money and bought the pressure cells and put it into the ground to get more information. And then we put the 3D geophones as 2 levels, and we put the pressure cell at the different levels. And again, our sensor over here, accelerometer, is on the roller. There's a GPS over here. There's a GPS next to these sensors, and these 2 GPSs are talking to each other to synchronize so that we know where the location is. Okay, so these are some of the picture that you see. These are some of the work, and we have the group of 4 old-timers and 1 newcomer. Mike was the newcomer. I was just complimenting, thanks to you guys. He's a guy who's has a PhD, and he's not afraid of pick and shovel. I was complimenting him. He was very helpful. And then we have Bob, Doug, Jack, and Len. These guys, they don't sit in their office. They come and help the researcher. We are used to they show us to the side and say, good luck, if you need something, come. These guys actively bring the equipment, and very quickly, and we put it, and we still have all the sensors into the ground, and they protect it. So these are some of the type of the information that you get. This shows you the vibration of the roller, the sensor on the roller. This is a close-up of it. And these are the vibration of the 3 accelerometers at 1 level. Actually, there are 6 of them. And you see that the vertical one is the white one, that, there's nothing, and then you get an response, and then you go after it, you're gonna lose the response. This is the close-up of what you do, and no equations. Okay. So the first thing we did, we just make sure that all the systems are working the same. This shows what the output comes from the CAT versus the one that we get it. They're fairly close, so we are comfortable that we can interchange the data between the different systems. And basically, this is one of the responses. This is the lower deflection. This is the one closer to the sensor. Now we have that one, and we can go and start doing the calibration. Back to my model. And these are the type of calibration we do. We don't believe in accept what the material you do. So why do we design? So that's one of the pet peeve we have as a geotechnical engineer. If design for 10 KSI subgrade, well, you should get 10 KSI, or design it for 5 KSI. So we routinely see that in some of the work that we do, the subgrade is designed, and you either you get a lot more modulus out of it or a lot less. So you either not putting enough pavement or you are putting too much pavement. So that's one of the benefits that we're going. And this is one thing we see. Okay, I'm wrapping up. That the type of the calibration you see, there are some differences. This is what the model says, this is what we are measuring, and this has to do because we use the laboratory modulus and the field modulus is different. So we have a transfer function we are working on. These are the type of the correlations we get, and basically we start mapping and looking at the different parameters. We do a different way of looking at the data, but that's beyond the point. All the field test that is done. And basically, one thing I would like you to show now, we start getting stiffness results from the roller for the first time, at least for us. So we can use it, and we thank you guys for giving. Sorry, I went over.
That's it. No more. You're never going to do it again. And what was wonderful what Soheil did is he brought in research that was not being paid by NRRA or any of the states or any of the associates, but stuff that we could tie off to related to MnROAD. They actually bought some of the sensors for us, so we didn't have to buy them. So that was a benefit also. Our next...
Can I say one thing?
No, you can't.
Anybody who's interested to participate in DOTs, we are starting phase 3 and we're looking for 4 DOTs to come. It doesn't cost you anything. The first thing you ask, how do I have to say nothing?
Yeah. Right, thank you. David White is our next speaker. Actually, is our next testimonial, and he works with Ingios. And again, he is working with looking at the different materials and doing non-destructive testing on that. So, David.
All right, good morning. Thanks for the opportunity to share with you some of the things about our company and our involvement with NRRA. I live just down the road, so I couldn't pass up the opportunity to be involved in some small way on the project. So I'll tell you a little bit about some of the things that we're involved with that we implemented on the project. The first technology is what we call our automated plate load test system. There we're bringing plate load testing out to the project in an efficient way. So we were able to perform some of those tests on a few of the different sections. The middle image is what we call validated intelligent compaction. The first time I was out at the low volume test track was, I think it was 11 years ago, when some of the research that MnDOT was working on was still in the implementation phases. So I've been involved with IC for quite a long time. Our company now has a kit and a system that we put on contractor machines to output in real time mechanistic design values. So we brought that and we're able to use that on a few of the sections. To the right is our IMA system. We do a lot of testing on geomaterials, trying to understand modulus, permanent deformation, stress relationships. And some of the things that we do with the APLT, we're not able to do with the IMA system. The IMA system, we can do 1 million cycles or 1 million easels over the course of about 10 days. So when we need to do accelerated testing, we bring some of those materials back to the lab. This is a little bit about our VIC system. It's a little bit different than what's available with some of the other equipment. The outputs are modulus. It depends on what the project requirements are. We also have the ability to sense what material type we're in. So if we're transitioning between virgin materials or recycled or subgrade, that's actually collected with the machine using some advanced algorithms. And that information is all routed through Microsoft in a secure environment and presented back to the report, to the client in the form of a report. So we generated several of these for the sections that we were able to work on out at MnROAD. Just a few more details in how this process works. There's an integrated sensor package that's installed, allows the operators to see information that's important, help them with their process control. It's field calibrated typically with APLT tests so that we have confidence and can provide a professional engineering report for the calibration. We display the results, we auto-generate reporting. That's such a huge element of intelligent construction is the data and being able to process that efficiently. Ultimately, we'll want to reduce risk. When it comes to pavement systems, my mindset is you can't build good pavement systems if you don't have high quality foundations. I'm just convinced of that from testing all over the United States and other locations, that we still have a serious issue with pavement foundation construction. I'm going to talk about that later this afternoon and how we can overcome that. One of the issues is our materials are just really complicated. All of the recycled materials that we work with, the gradations, the blends of recycled materials, stabilizers, complicated stuff. So as part of the VIC, we've been cataloging and have calibrated 40 different materials now, covering a range of base and subgrade materials. Through this process, we've discovered that traditional methods of defining quality probably need to be updated a little bit, especially in terms of the changes that have occurred in design. So I won't go through all the equations here, but we've come up with a set of what we think are really important quality indicators for pavement foundation systems, and there's 5 of them. And typically we color code them red or green so that people can quickly determine if they've met those or not. And I mentioned all this information's got to go to the cloud. So we've been working with government agencies to develop tools that work for their specific needs. So this display here is a set of icons that allow the agency to access different bits of information on the project. Some of it relates to what's happening right now. I want to see compaction mapping to what are the trends over the last several weeks in control charts. There's some mobile versions of that and rapid email alert systems. I think this slide summarizes kind of one of the key features of the VIC system. It's color coded, so blue is stiff, and you can see that in the upper left, validated with independent testing, and then the lower left is low stiffness. And what was so interesting about this is all of this passed the tollway's traditional QC and QA methods, but built into this foundation system were some defects that we believe are going to cause distress to pavement systems. So we're really after trying to identify those, help the contractor locate where they're at, and then make decisions to improve those. This is just an image of our APLT system. This was a really interesting project because we had the opportunity to test about 100 locations on an existing interstate on the tollway system before the design was going to go forward. So this section is going to be rebuilt, and we had the opportunity to test what was in the foundation beforehand. And this is the IMA system back at our shop. in Northfield, where we'll do about 1 million cycles in 10 days. One of the really interesting things, this might surprise some of you, is that resilient modulus isn't constant over the life of loading. It actually changes. So we've been trying to understand that and relate it to permanent deformation under loading as well. I'll talk more about this afternoon, but we have what we call tenets of measurement. And again, these are things that we believe are really important to making sure pavement quality is where we want it to be. Pavements last a long time, and a lot of it has to do with directly measuring what are the important engineering properties. So just to wrap up, here's a couple snapshot from some of the things that we saw out at MnROAD from this summer. You all know there were a lot of different sections. These are some of the profiles that we had the opportunity to do the mapping on. And it was really fantastic. Virgin materials, recycled materials, stiff subgrade, soft subgrade, and really, really soft subgrade. We looked at the participating state design methods, because really what we wanted to do is be able to relate the measurements to whatever the design methodology was for those different states. So you'll see K value, MR value, IBR value, R value, CBR. The states that participate have different sort of mechanistic values of interest for their design. So this is one example. This was section 27. The color coding output here is based on resilient modulus, and you can see there's a fair bit of variability, values from less than 8 KSI to over 20 KSI. And this was the section, this was the subgrade section, and then this was the base section. And you can see that the base stiffness tends to reflect the subgrade stiffness beneath that. We calibrated all of this on site, developed our models. In the end, from all these different sections, these are statistical box plots of modulus. So within a section, you can see the spread of the data is an indication of the variability. All the different sections were quite different. Some were uniform, some were highly variable. And that's data that we continue to look at today. And these are just some of the locations that we've been working here for the last a couple of years. That's all I got. Thanks.
Alrighty, our last testimonial was Luke Pinkerton from Helix. And he was quite instrumental in kind of working with the fiber test sections, his whole industry, in fact. But the idea is that we haven't used a lot of fibers, so again, that's why we really need industry to help us out in these areas that are new and upcoming. So, okay. Be quick if you can.
Yeah.
You're in charge of lunch.
All right. Yeah, thanks, Ben. I really just wanted to take the opportunity to thank the NRRA and Ben and the whole team here for such an opportunity to get involved in short order. Our company makes twisted steel micro reinforcement. It's a 1-inch long steel reinforcement that's shaped like a screw that you mix into concrete. And we first kind of came into contact with NRRA about this time last year. We joined the organization after I had an initial meeting with Ben and the team. And then I joined the first rigid team conference call, and they were talking about these partial depth repairs. And I'm scratching my head a little bit, and I'm like, well, this would be a great opportunity to look at how our product Helix, which is this is what it looks like. It's 12 inch or 25 millimeters long, zinc coated. We also make a stainless steel version of the product. How it would benefit these partial depth repairs. It drives me crazy. I drive to my factory and every single joint is broken up on the highway there. There's got to be a better way. So I've been working to try and get involved with DOT research for years. We have the product approved and in installations in about 10 states at this point. But to get into a section, an actual official research section like this has been very difficult. So the opportunity and how it came up so quickly was tremendous for us. And it just so happened at the time we were working with CTS on another project out in Los Angeles that was more architectural, where we had done some testing, incidentally, right here at Element Labs to determine the increase in flexural strength and compressive strength you get when you add just 2 pounds of our product into the standard rapid set repair mortar that they have, which is very similar to the DOT repair mix. And in essence, what we get is a 50% increase in that flexural strength. And that's something that's very unique for our product. There are a lot of fibers out there. Most of the fibers will focus on what happens after the concrete cracks. This product actually significantly increases the initial flexural strength of concrete. So that means we can make concrete thinner, we can make it more durable, but then it also has that durability and that toughness benefit that comes after the crack. So you get sort of both what we call the proactive benefit before the crack and that post-crack benefit that's more traditional for fibers. So we were able to work with Ben and Jerry and then the team at CTS to, it so happened that one of the cells was available, cell 13 of the partial depth repair section. Within a matter of a few weeks, we got all this organized and we were able to install these repair sections. So this is, for those of you who didn't see this yesterday, this is kind of what these repair sections will look like. Some of them were long like this, and then there were some smaller ones where they went and milled out a section. And then you can see the section of the Helix reinforcer. You can almost see the Helix in there. It's hard to see once it's in the concrete. A lot of people ask me, will this stuff stick out? Will it pop a tire? But once it's finished, you don't even see it below the surface. We're lucky enough to get 2 sections. One section has our standard product, which is made of zinc coated steel. And then there's also a stainless steel section or stainless steel product that we had. So we'll be able to compare the difference between the stainless versus the zinc coated. Obviously the zinc coated is a little less expensive, but the stainless will provide us, sort of the best corrosion resistance. And what better environment than here with all the de-icing agents and what that this will see over its life. So the CTS team was really great to help us install it, and that's what it looks like. We do a lot of other applications with this based on that modulus of rupture and that benefit, that post-crack benefit. Going along with sort of that repair technology, I'll just mention that Missouri, who's also one of the members of the NRRA, has tested, evaluated, and is now using Helix to do partial depth repairs on bridges. Very similar concept. So we're seeing, more and more implementation of the product in that sort of realm. It's what the finish looks like, and sort of the finished product. So again, I'd just like to thank NRRA for the opportunity. We're really looking forward to participating over the life of this research project and hopefully getting involved with more in terms of the fiber group, as well as hopefully getting more full depth pavement opportunities. So thanks.
Yeah, thank you.
Yeah.